before joining Goldman Sachs, I used to work in the mining industry, and I was not directly involved in shipping, but I do remember the very first time I went to Rotterdam and got on a Capesize vessel, and I thought it was pretty cool. So I've had a little bit of exposure to shipping since then. Before I get into this short presentation, I want to make two observations about these coming sulfur regulations. The first one is, when talking to people in industry and manufacturers and fuel providers, we have found that there's obviously not a lot of consensus going on. We hear very different opinions to a greater degree than what we see in other industries. So I think this is interesting in itself. And the fact is that it's not an easy problem to analyze. I think reducing sulfur emissions from shipping brings people from the shipping industry, of course, but it also involves people from the oil and refining sector. And to some extent, there's a little bit of power generation involved as well, because you're talking about scrubber technology and you're potentially talking about LNG and should you put more fuel into the power sector. And these are three industries, so shipping, oil/refining, and power, that usually don't talk too much to each other. And now you have all this overlap, and that's partly what makes things a little bit tricky to get our heads around. So, Kirsty has asked me to keep this relatively short, so we can get to the panel discussion. What I'm going to do is going to describe how we're thinking about the equilibrium, so how does the industry comply with the lower sulfur regulations, and then talk about what are our expectations for how this equilibrium will be achieved. All right. So this is probably not news to anybody. There are a number of ways in which you can achieve compliance. So starting with the ship owners, you can just wait for the low sulfur fuel to come to you. Or you can invest in a scrubber, or you can invest in LNG as your new fuel. And if you're a refiner, there's a number of things you can do. You can, first of all, just wait for these increasing capacity that you invested in some time ago. You can optimize fuel oil in the system and put the high sulfur fuel oil where it should be and the low sulfur fuel oil where it should be. You can do the same thing with feedstocks and crude, and again, optimizing for sulfur. You can increase the utilization rate of your cokers. You can also just bring in more crude to produce more fuels of all types. And finally, you can try to adjust the yields between gasoline and diesel. So a number of things the refiners can do, as well as the shippers. The second point here is everybody's going to try to maximize their profits. That's the way the market works. We think that rational solution from a sulfur perspective may not necessarily be the optimal one. If you're thinking, how can we reduce sulfur emissions from the shipping sector at the lowest cost to society? And we'll get to that in a minute. This problem is also a bit tricky because, of course, what one party does will affect the decision-making of all the other parties. So let's get into these different elements, starting with scrubbers. So when we look at the shipping market, we do think that it's all about size. Ships that have big engines, that spend a lot of time at sea, and therefore have high rates of fuel consumption, the economics do look quite compelling. Smaller ships, much less so. And one point I want to emphasize here is, if you look at the size of the shipping fleet, it really is the top 10 to 15% of ships that account for nearly half of fuel consumption. That's where your potential market is going to be. So, vessels on long routes, sailing a lot of the time, don't spending too much time at port, big engines, they will have amortization periods on paper of 1 year, 2 years, and I think that is attractive enough to make scrubbers interesting. To be fair, we have heard from a lot of people all the risks of using a scrubber. What happens if the scrubber breaks down? What happens if you go with a scrubber manufacturer that you haven't heard about, that is going to give you performance guarantees? So there is some complexity you're introducing to your ship. There are clearly some risk associated, but on the other hand, you have that potential gain from having lower operating costs than your competitors. Another thing we keep hearing is about the capacity to produce and deliver scrubbers, that only so many ships, only so many scrubbers can be delivered before January 2020. So we'd say, of course, there is a limit, but we also believe that the scrubber manufacturers actually have a good incentive to expand that capacity. Our understanding is the constraint is not the manufacturing itself, it's not the materials. We don't think it's necessarily the dry dock space. It's more the skilled labor, the people who look at the specs of the ship, try to find the right model, start preparing for the installation process. We have found that there are actually a lot of scrubber manufacturers out there, all trying to get a piece of this market. So we think that we may be surprised by the capacity of the scrubber industry in totality to take on new orders. The other potential option for the shippers is LNG. In my day job, I cover the LNG market, so it's a field that I quite like myself. But I think the fit for shipping is not that great. Yes, it is cheaper, and the chart that you see on the left actually underestimates the cost advantage of LNG, because LNG right now is close to a seasonal peak. We think LNG prices in the medium to long term are probably, would be about 30% lower than what you see on this chart. So it is a cheaper fuel in dollars per MMBTU or dollars per gigajoule basis, but it is also a relatively high capex option for ship owners. So it would make sense if you amortize that over a big volume of fuel consumption. So it makes sense for the very largest engines, like very large container ships. But elsewhere, I think the economics look less compelling. And we also view the environmental angle with a little bit of caution. Yes, LNG is very clean, no sulfur, very low nitrogen, very low particulate matter, but the carbon angle is the one that we would challenge. And the chart you see on the right shows how we typically measure emissions from fuel oil versus LNG in a ship. So LNG emits less. We're not questioning that. So let's assume you're getting a 25% reduction in emissions at the ship level. I think increasingly the regulators and policymakers will start to look at life cycle emissions, not just emissions where you're burning the fuel, but also the emissions upstream, from the moment you produce the fuel to delivering it to the ship or the power plant. And I think that's where LNG starts to come short a little bit, because to make LNG, you actually need to consume a fair amount of energy to bring it down in temperature. And then there are potential leaks of natural gas on the pipelines and the gas wells. We don't have a lot of data at this point to quantify what we call fugitive emissions, but that is going to change. We think there's going to be more information to quantify those emissions, and I think the greenhouse gas advantage of LNG may appear less compelling in the future than it does today, when all you're doing is looking just at the emissions from the stack. Last point I want to make about the shippers is the question of uncertainty. I think this is an important point. What this chart shows is the distribution of fuel spreads, so call it HSFO to LSFO or to distillate. You have an idea of where it's going to be, but you don't really know for sure. And if you're really uncertain about how it's going to play out, then your low and high is going to be very wide apart. So whether you, for example, decide to buy a scrubber or not, you know that the higher the spread, the more attractive it's going to be to buy a scrubber. But if you are uncertain about the spread, then you know that there's a decent chance that buying a scrubber will be the wrong choice, because you would end up somewhere on the left side of this curve. So the point here is, when uncertainty is high, people often delay investment decisions. And you wait for that uncertainty to diminish, which in this chart would mean that curve would get narrower and narrower, and the probability that you would lose money on the scrubber would diminish until it's negligible. So why were people reluctant to go for scrubbers in 2016 and 2017? Because there was still a lot that wasn't known about, for example, the enforcement and compliance of the sulfur rules. Why was there a big increase in interest starting this year? Because now some of that uncertainty is going away. With the July meeting, and I would imagine the October meeting, taking away a lot of that uncertainty for good. So at least it helps people in the industry make decisions with less uncertainty. Now, moving on to the refining side. So for ship owners, there's a binary decision. Do you invest in a scrubber or not? Do you build LNG engines or not? For the refiners, there's no capital investment required. All they have to do is rejig how their operations are going to work. And I'm going to go through the 6 options in the order of lowest cost for them to highest cost for them, and therefore for the rest of us. So first up is the refiners have actually a lot of capacity coming to the market. This has nothing to do with IMO. It has a lot to do with the fact that fuel oil consumption in the world is declining. It's declining in power generation in particular. The refiners know that, so they're going to configure the refiners so they produce less fuel oil because there's less demand for it. And margins in refining have been quite good. So they invested money. This was before 2016. The capacity that's growing, and here I'm describing in these acronyms refer to the different bits of a refiner that help to get rid of sulfur, so cokers and crackers. So that we think is going to produce more low sulfur fuel and remove a decent amount of high sulfur fuel from the market at no cost, because the capacity has been built, so they don't need an extra incentive to make it work. The next solution is to optimize fuel oil in the market. So the chart on the right, what it shows is the sulfur content of fuel oil around the world. And as you can see, there's a range. Some fuel oil is high sulfur, close to the 3.5% limit. But there's a certain amount of fuel oil that is actually already low sulfur. Now, right now, there's no reason why you would send that necessarily to the shipping industry, because the 3.5 sulfur cap is high. So we believe some of that low sulfur fuel is actually being used in the power sector. Starting 2020, that's the wrong choice, of course. So you would need to take this fuel oil away from the power sector, give it to the shipping sector, and replace it with higher sulfur fuel oil. Why does that work for the shippers? I mean, it's obvious. For the power sector, it works because power plants have scrubbers already in most countries, so they can take more sulfur. And in countries that don't have emissions control, then they're not measuring that type of pollution anyway. So we think rearranging fuel oil flows around the world is something that is a low-cost solution. You do need to probably spend more money in transportation because you're moving and changing the flows of this fuel, but we think it's a relatively low-cost option for the industry. The other way the refining industry can work to reduce emissions in shipping is to do the same thing with crude. So you're going to give the sour crude with high sulfur to the refiners that actually have the capacity to take a lot of that sulfur away. So again, this is not necessarily happening all the time today because there's no reason to optimize for sulfur, but give the industry a reason to optimize for sulfur, and they'll organize what is the high sulfur content going to the refinery that can separate that, the high sulfur fuel oil going to the best cokers, and take the low sulfur contents to the less advanced cokers. We think that's another solution that the refining industry will do. And again, you don't need to have a big change in prices for this solution to happen. Sorry. Now the chart on the right shows coker utilization rates. So here what's interesting is this is the type of equipment in a refinery that can take high sulfur fuel oil and remove some of that sulfur. So if there is already some capacity available, particularly in North America and to some extent in Asia, then again, that's a relatively easy solution that you can take. You would need here to have a good reason to do that if you're a refiner. So you need to see the price spread between high sulfur and low sulfur to start to grow further. So we're going from cheap solutions to more expensive solutions. So here, if you are going to ask a refiner to push their coker units harder, then the prices of fuels need to start moving a little bit further. But again, here you have a little bit of extra change in the type of fuel that would be coming to the market. Then there is, of course, the option of simply producing more crude. And if there's more crude, then you end up having more of everything. And again, there is some spare capacity to do that. Refiner utilization rates, particularly in China, are not terribly high. So if you had an extra 1 million barrels per day of oil in the world, some of that can go to China without needing more investment, and you would end up having a certain amount of compliant fuel right there. But again, this has another impact on fuel prices. You're now having to incentivize more crude production, which is a bigger ask than the previous solutions. And this also brings to the question, if you're going to require more oil being produced and you're not consuming all the heavy sulfur fuel oil, what is the interaction between shipping and the power sector? And here, I think, again, the answer is not obvious. What you see on the left side is where in the world are liquid fuels used in the power sector. So this is fuel oil, crude, and diesel. And we think countries or regions that could take heavy sulfur fuel oil and burn it in power plants, Saudi Arabia looks like the best candidate. They are a huge energy consumer, and we think it's quite feasible for them to, import heavy sulfur fuel oil if necessary and deliver it to their power plants, especially the ones near the coast. And actually, it would make sense for them because that would displace some of the crude and diesel that they're burning, which is a higher value fuel. So that would be the incentive for them to do this optimization. But I think for this to happen in a big way, you would need to have a requirement for more fuel and more oil in the first place, and I think that's not a foregone conclusion. We may not need the power sector to help us balance the sulfur market in shipping. So these are the solutions that we see. Conceptually, what does it look like? We find that a good way of putting everything together is to think about the solutions to consume heavy sulfur fuel and the solutions to convert heavy sulfur fuel and replace it with low sulfur fuel, put them all side by side. So the horizontal axis is million barrels per day. So that would need to add up to 3.3 million barrels. And on the vertical axis is what is the change in the fuel price that you need for those solutions to happen. So of course it's going to be all mixed together, but I would say that the cheapest way to comply is actually not to comply. So there's going to be some non-compliance, some of that will be voluntary, maybe in certain regions of the world. We think there's going to be a small size of the market. There's going to be some involuntary non-compliance when there's a shortage of fuel. We think that those instances may be pretty short-lived because if you have a FONAR, because there's no compliant fuel, we think that's a pretty strong signal to a fuel supplier to send the tanker straight away because the price they will achieve in that particular port is probably going to be pretty attractive. So that's the first step. The second step is the expansions of the refineries. So again, these are happening anyway. They're not committing new capital to help IMO 2020 compliance. It's happening already. So very, very low cost, close to zero. And then you have everything else. So very large ships going with scrubbers, very, very large ships, a few of them going with LNG, the optimization of fuel flows in the refining industry, and then moving to the more expensive solutions like pushing cokers harder, all the way to potentially requiring more oil production. So it's a range of solutions. They all depend on one another. This cost curve, in a way, is going to be different in 2021 versus 2020, and it will change again in 2022. And it's not a straightforward problem to analyze, but that's how we're thinking about it. And I'll wrap it up by talking briefly about how our base case solution is. So this is an analysis that my colleagues published in May of this year. I'm sure that we will get back to it and continue to refine it. But to summarize, I would say we are becoming more positive on scrubbers than before. We think the capacity of scrubber production and delivery is probably increasing and may surprise us a little bit. We think that the need for oil production to increase overall is probably going to be modest. I think the refinery industry can do a lot simply by optimizing the way they're supplying shipping. And to the last point about uncertainty, I think if in a perfect world, companies would have done their investments and their decisions over a period of time that would be longer than just 2 years. I think by having this uncertainty continue for another 12, 18, 24 months, longer than necessary, we're going to end up with an equilibrium that is not the lowest cost solution for the economy in terms of fuel prices, but the market will eventually balance, if not in 2020, then in the few years afterwards. So with that, I'm going to wrap it up and hand it over to Kirsty. Thank you.